We will continue the discussion of the nomenclature so far the IUPAC system is concerned. Last class we have discussed till ether. Today we will start with the class of the compound is your aldehyde. GF I have written for general formula, it is RCHO, where R is hydrogen, it is an exception. Normally R should be alkyl group, but here R may be hydrogen. Minimum number of carbon atom required is 1. Functional group is CHO. This class of compound contains suffix only, that is Al. The last letter E of alkane is replaced by Al. Therefore, the complete name is alkanal. Few examples I am giving you: HCHO, methanol, CH3CHO, there are 2 carbon atoms, ethanol, say CH3CH2, CHO, it contains 4 carbon atoms, butanol. Next category will go is your ketone. Eighth category is your ketone. The general formula is RCO R dash. Here R and R dash may be same or different alkyl groups. It is never hydrogen. Minimum number of carbon atom is 3. Functional group is C double bond O. It also contains suffix as ONE. That means from alkane, E is replaced by ONE. Hence, its complete name is alkanone. Few examples: it contains minimum 3 carbon atom, is your propanone, CH3. It contains 4 carbon atom, butanone. But if there are 5 carbon atoms, you will have to mention the position. This is 2-pentanone, or you have got another choice, you can write pentanone 2, or you can write pentane between primary suffix and the secondary suffix 2. One more example, having same 5 carbon atom, CH3 CO. This is 3-pentanone, or you can write pentanone 3, or you can write pentane 3. So this is regarding ketone. The next one is acid. Acid. General formula is RCOOH. Here again R can be hydrogen, which is an exception. Normally R stands for alkyl group or alkyl group. Minimum number of carbon atom is 1. Now the functional group is COOH. Now it contains also suffix, that is oic acid. From alkane, you replace the E by oic little space acid. So the complete name is alkanoic acid. Few examples, say HCOOH, this is your methanoic acid. CH3COOH is your ethanoic acid. It contains, say, 3 carbon atoms, propanoic acid, and so on. This is regarding acid. 10th one is acid halide. It is acid halide. General formula is RCOX, where R is maybe hydrogen because the original acid contains hydrogen, or alkyl group. Minimum number of carbon atom is 1, and the functional group is COX. X stands for either fluorine, halogen, fluorine, chlorine, bromine, or iodine. It has also suffix OYL, oil halide. That means from alkane, you replace the E by OYL, and for halogen you write halide. So complete name is alkanoyl halide. Alkanoyl halide. Few examples I am giving you. Say HCOCl, methanoyl chloride, or CH3COBr, ethanoyl bromide, or CH3CO. Let us increase the carbon atom, CH2CO, say iodine. This is your propanoyl iodide. So this is regarding acid halide. The next category is your acid amide. Amide. General formula is RCONH2. Again, R can be hydrogen or alkyl group. Minimum number of carbon atom is also 1. Here the functional group is CONH2. It has a suffix of amide. That means from alkane, you replace the E by amide. So the complete name is alkanamide. Let us take few examples. HCO and H2. This is your methanamide. CH3, CH2, CO, and H2. There are 3 carbon atoms, so it is propanamide. Next category is acid anhydride. Acid anhydride. There are two types acid anhydride. One is general formula RCO OCO R dash where R, because it's the first category I am discussing. RCO. R can be hydrogen or same alkyl groups. There are two alkyl groups are same. Here n value will be even number 2, 4, 6, 8 and so on. Functional group CO, O, CO. Now it has a suffix also, that is oic anhydride. That means from alkane you replace the E by oic, another one is anhydride. Therefore the complete name will be alkanoic anhydride. Examples I am giving you is HCO, OCOH. So imagine a line through this oxygen atom, see both sides are same. So this is your methanoic anhydride. Similarly, here also both sides contain 3 carbon atoms. Name is propanoic anhydride. This is, you can call it 12-bit 1, where two alkyl groups are same. Two alkyl groups here may be different. That is the second category of anhydride. Second category of anhydride, say R and R dash here. R and R dash are different alkyl groups, and one of them may be hydrogen. So here n value will start with 3, 4, 5 and so on. Functional group same. Here suffix is 2 times oic, again oic anhydride. These you will write in alkanoic, that means in alphabetical order. So from alkane E is replaced by oic and oic anhydride. So you will have to write as alkanoic, again alkanoic anhydride. These two alkanoics what in alphabetical order. Alphabetical order. I am giving you few examples. Say HCO. So you can see this side contain 1 carbon atom, methanoic. This side is ethanoic. E comes before M, therefore name is ethanoic, methanoic anhydride. This is in alphabetical order. One more example, say CH3, CH2, CO, O, CO. So you can see this side 3 carbon, this side 5. 3 means prop, here pent. P both case same, so PR, this is PE, so PE will come first. So P, so it is pentanoic, propanoic, anhydride. So anhydride are of 2 types. In one case, both the alkyl groups same, one of them may be hydrogen. In second case, alkyl groups different, one of them may also be hydrogen. Next is 13. Is your ester, by ester you can call. General formula RCO, R dash. Here R can be hydrogen or alkyl group, but R dash is alkyl group, most alkyl group, cannot be hydrogen. N value will start with 2. Functional group is your COO R dash. This compound contains prefix. This R dash is named as alkyl. First, it has also suffix is OATE. So the complete name is alkyl alkanoate. Here E is replaced by, from alkane is replaced by OATE. Examples, say HCOOCH3. This is methyl. It also contains 1 carbon atom acid. So methyl methanoate. Another example, let us say this is methyl, 3 carbon atoms, propanoate. So alkyl group is named first. There is an alkyl, so it has a prefix, that is alkyl. Suffix alkane is replaced by OATE. Next is nitroalkane. Nitroalkane, general formula is RNO2. R stands for alkyl group. Now here the N value remain 1, 2, 3 like that. Functional group is NO2, that is called nitro group. Nitro group, and it has a prefix of nitro, and suffix is same that of alkane, remain AM. So complete name will be nitroalkane. Nitroalkane. Few examples. Say CH3 NO2. This is your nitromethane. Similarly, CH3 CH2 NO2. This is your nitroethane. But if it contains 3 carbon atoms, and onward, you'll have to use the position. I have already written for position, you have to write before the name. At position 1 there is a nitro group. This is your 1 nitropropane. With same 3 carbon atom, nitro group may be at position 2. This is your 2 nitropropane. So this is regarding nitroalkane. Nitro group is After 3 carbon atom position to be mentioned, now the position should be before the name. Next is alkane nitrile. Alkane N-I-T-R-I-L-E, nitrile. General formula is RCN. R is alkyl group. N value will start with 2, 3, 4 and so on. Here the functional group is CN. CN. It has a suffix only. Suffix is nitrile, but E is not dropped from alkane. E is remain. Only an extra nitrile word you are using. So complete name is alkane nitrile. E is written. E is written. Few examples we can take. Say CH3CN, ethane nitrile, or CH3CH2CH2CN. There are 4 carbon atoms, so it is butane nitrile. So here E is written, E is not replaced. Only one extra word, nitrile, you are using. And the last category is your amines. Amines. Amines are of 3 types. Amines are of 3 types. So to start with, let me discuss primary amines. General formula RNH2. R may be alkyl group. N value start with 1, 2, 3 and so on. Functional group is NH2 group called amino group. Here it contains suffix only, that is amine. That is E of alkane is replaced by amine. So complete name becomes alkana amine. Few examples: CH3NH2. This is your methana amine. CH3 CH2NH2. This is your ethana amine. But if contain 3 carbon atoms, position has to be used. Here position you can write before the name or after the name, but better I will tell you, write in between. Propane 1 amine. With having same 3 carbon atom, another structure may be, that is propane 2 amine. So after primary amine, which is general formula RNH2, I am proceeding to secondary amine. Here there is another alkyl group. So R and R dash may be same or different alkyl groups. So minimum number of carbon atom here will be 2. Minimum number of carbon atom will be 2. Functional group is NH. This is called imino group. Now this compound contains a prefix, that is N-alkyl. Here the alkyl group contain less carbon atom. If both sides same, it is immaterial. Suffix if same that of primary amine, same that of primary amine. Examples, let us take CH3NH. So here both the alkyl groups same, so you can write any one of them, that is N-methyl, N should be capital, N-methyl methana amine, N-methyl methana amine. Another example says CH3 CH2NH. Here I am writing 3 carbon atom, this side 2, this side 3, so alkyl group will be N-ethyl. For position 1 nitrogen is written attached, it is called propane 1 amine, because there can be another structure where nitrogen may be attached to the second carbon atom of the propane. This is N-ethyl propane 2 amine. So it is N-alkyl alkana amine. The last one, that is tertiary amine, tertiary amine. So general formula becomes Rn, R dash, R double dash, where R, R dash, R double dash may be same or different, or may be different alkyl groups, or two of them may be same and one is different. So there is 3 probability. All 3 alkyl groups may be same or may be different, or 2 of them same, one is different. So minimum number of carbon atom is 3. Functional group is called tertiary nitrogen atom. Here there will be 2 types of names where prefix is different. Prefix may be, if 2 alkyl groups are same, that is NN dialkyl, that is containing less carbon atom, and another prefix when 2 alkyl groups are different, this is N-alkyl, but these 2 in alphabetical order. Suffix is same that of primary amine, same that of primary amine. So there can be 2 types of prefixes, either N dialkyl, that is when less carbon atom, here also N-alkyl in alphabetical order. More number of carbon atom will be the as per the name of the primary amine. So since the last one I am rubbing it out, I am giving you a few examples. Say in all the alkyl groups are same. So these 2 I will take N dimethyl methana amine. Let us take another CH3 and CH2. Say these are the 3 all are different. So this is more carbon, these are the last 2 carbon atom. Alphabetical order is N-ethyl, N-methyl, propane, 1-Me, because there can be another structure, say CH3 and CH2, CH3, CH having 3 carbon atom also. So this is an ethyl and methyl propane 2-Me. So this is all about the nomenclature. There is a lot more, but due to shortage of time, I am not going to discuss the rest of the nomenclature. Now I shall proceed to another most important portion of organic chemistry, that is fundamental concepts in organic reaction mechanism. Fundamental concept in organic reaction mechanism. There are about, say, 8 different things I shall have to discuss. To start with, I am going to discuss your number 1, electron displacement. One by one I will discuss. So far the concept of reaction mechanism is concerned. Number 1, electron displacement. Now electron displacement in an organic compound may take place either due to presence of some atoms or groups or substituents. This cause permanent polarization. Here most of the time I will use the word polarization, which means separation of charge. There are some atoms or groups or substituent which permanently displace electrons. Under this will come your inductive effect, or resonance. All these things will come, resonance and inductive resonance, NaNCE. Resonance will come under this. So here permanently electron is being displaced due to presence of certain atoms or groups or substituents, and sometimes due to presence of some charged particle or charged atom particle, or called attacking reagent. They are responsible for the displacement of electrons, but that is a temporary effect. Under that will come your electromeric effect, also polarizability effect, polarizability effect, etc. will come under that head. So electron can be displaced either due to presence of some atom or group or substituents, or due to attacking reagent. First category is a permanent effect, second category is temporary one. Next is your inductive effect. Most important is your inductive effect, or called I effect. Now, in organic compounds, carbon hydrogen bond is taken as a non-polar. There is no charge separation. This shared pair, most of the time I will use this shared pair of electrons remain exactly in between carbon and hydrogen. Say an atom or group, say X, which is more electronegative than carbon, is attached to it, then the shared pair of electron will be more shifted towards X in comparison to carbon. Therefore, carbon develops slight positive charge, X develops slight negative charge. Here X is more electronegative than carbon. On the other hand, there may be an atom or group, say Y, which is less electronegative than carbon. Then the shared pair of electron will be more shifted towards carbon, by which carbon develops slight negative, delta negative, and Y develops slight positive. In this case, Y is less electronegative than carbon. So you can see permanently CX bond or CY bond is polarized. This permanent effect by which either CX bond or say CY bond is polarized is called what is your inductive effect. Inductive effect. Permanently it is polarized. It symbolizes an arrow, but arrow mark is in between, not at the end. It is symbol for inductive effect. Inductive effect are of two types. Inductive effect is two types. Bit one, negative inductive effect, that is called minus I effect. Now there are some atoms or groups which withdraw electron towards it from carbon, which withdraw electrons from carbon towards it. Their example is relative order I am writing. Nitro group is maximum, then cyanide, which is greater than carboxyl group, greater than fluorine, which is greater than chlorine, greater than bromine, greater than iodine, greater than OH, greater than your methoxy, again greater than C6H5, this is called phenyl, and hydrogen is taken as a standard. So these groups, they withdraw electron towards it. On the other hand, if there are some atoms or groups which pushes electrons from it towards carbon, is called positive inductive effect. So these groups above one is said to possess negative inductive effect. Positive inductive effect when groups are capable of pushing electron away from it. They are said to possess positive inductive effect. Say, this is tertiary carbon atom, has got a maximum, it pushes, then the secondary carbon atom, then the primary carbon atom, then only hydrogen. So these groups, they are capable of pushing electron away from it and they withdraw electron from it. Next I am going to the electromagnetic. This is a permanent effect. Third one is your electromagnetic effect, which we call it E effect. Now in this case, due to presence of a charged particle, the pi electrons of a multiple bond, I have already told you, double bond or triple bond is shifted from one atom to another. So long as the charged particle is present, this shifting you can feel. But when the charged particle is removed, it will regain its original position. It is a temporary one, shown by curve arrow from the atom from which electron is shifted to another one. It is again two types, negative electromagnetic effect or minus E effect. Now here, in presence of a charged particle, the electron is shifted from pi bond away from it. Say if we take a carbonyl group, in presence of a cyanide minus, electron is shifted from carbon to oxygen away from the attacking reagent. Cyanide is your attacking reagent. So you can find electron is shifted away from the attacking reagent. On the other hand, if electron is shifted towards the attacking reagent, then it is said to possess positive electromagnetic effect. That is called plus E effect. Here, say if we take C double bond C, if it is attacked by some, say, H plus addition, so what happens? Electron in pi bond is shifted towards it. So when electron shifted towards the attacking reagent, it here at H plus is the attacking reagent. So electron is shifted towards in a pi bond. Pi bond means when there is double bond or triple bond, electron is shifted towards it, then it is said to possess positive electromagnetic effect. If it is shifted away from it, as already I have given examples of attacking of cyanide ion, then it is said to possess negative electromagnetic effect. Next we shall proceed to your fourth one is your resonance. Now if for a compound or for an ion, two or more different structures are being written are being written only by differing in the distribution of electrons, nothing else. Atomic skeleton remain constant, electrons. Then all these structures are called resonating structure or canonical structures, and this phenomenon is known as resonance. So what I have written, if for a compound or for an ion, two or more different structures are being written only by differing in the distribution of electrons, atomic skeleton does not change, then all these structures are called resonating structures or canonical structures, and this phenomenon is called resonance. I am giving few examples to illustrate the resonating structures of different compounds. Say for example, let us take sulfur dioxide, sulfur double bond O. There is a coordinate bond from sulfur to 1. So this is one structure. In between two resonating structure, double arrow is given. Another resonating structure is this one. So compound 1 and 2 are two resonating structures of sulfur dioxide. If we take sulfur trioxide, it can be, this is structure 1. Another possible structures, you can see only the electron distribution is being changed, nothing else. So these are the three different structures, three resonating structures of structure 1, 2 and 3 are three different resonating structures of sulfur trioxide. Similarly, if we take benzene, you can write two different resonating structures. So compound 1 and 2 are two different resonating structures of, say, benzene. If we take another example, say carbon dioxide, in both cases this is a double bond. Electron may shift it from one place to another, giving you O plus, minus, or another possible resonating structure may be O minus, plus. So these are the three different resonating structure of carbon dioxide. Now, due to resonance, the molecule becomes stable. The stability depends upon number of resonating structures. resonating structures. More the number of resonating structures, more is the stability. Remember, more is the number of resonating structures, more is the stability. Therefore, sulfur trioxide is more stable than sulfur dioxide, because we have seen for sulfur trioxide there are 3 resonating structures, but for sulfur dioxide there are 2 resonating structures. Again, this resonates, there are also 2 effective, or say 2 types, bit 1 negative resonating effect or minus R effect. Now, certain groups like say nitro group or aldehyde or say carboxyl groups or cyanide, when conjugated, conjugation means having alternate double bond. Conjugation means having alternate single and double bond, single and double bonds, single and double bonds. So these groups, when conjugated with say benzene or some unsaturated system, are capable of withdrawing electron from the unsaturated system, are said to possess negative resonating effect. The next one is positive resonating effect. Positive resonating effect, or called plus R effect. Here the groups or atoms like say OH group or say amino group or say halogen, where X stands for fluorine, chlorine, bromine, iodine, etc., are capable, when attached to conjugated systems like say benzene or unsaturated systems, are capable of pushing electrons to the conjugated system, are said to be possess positive resonating effect. So resonating effect are 2 types. There are some groups which withdraw electron from the conjugated systems like benzene or say unsaturated system like ethene, butadiene, etc., and some are capable of pushing electron to the conjugated system. Next is, I think 5th one will be hyperconjugation. This is extension of resonance. If there is a say carbon hydrogen single bond is called sigma bond. Remember, all single bonds is sigma bonds. Then there is a double bond, one of them is sigma and one of them is pi. In a triple bond, one sigma and 2 of them is pi. Now, so far hyperconjugation is concerned, when there is a carbon hydrogen single bond attached to an conjugated system of unsaturation, this sigma bond electron is shifted towards this conjugated system. Say for example, propene. So you can see there is carbon hydrogen single bond. This is unsaturated system. This sigma bond electron is shifted. This is your propene. electron is shifted. So you can find H plus CH, CH2 minus. There can be another structures, double arrow, H plus, that means this carbon hydrogen bond electron is shifted, giving you CH2 minus, or there can be this hydrogen electron may be shifted, giving you CH2 minus. So structure 1, structure 2, 3 and 4 are 4 different hyperconjugated structures of propene, where you can find the carbon hydrogen sigma bond electron is shifted towards this unsaturated system. Now this is evident from the fact that this is carbon atom 1, 2, 3. Originally carbon atom in between C2 and C3 there is a single bond. So bond length should have been 1.54 angstrom, but it is observed is 1.49 angstrom, which is less or smaller than the single bond length, which proves that there is the presence of what is called or contribution of these hyperconjugated structures. More the hyperconjugated structures, more will be the stability. More the hyperconjugated structure, more will be the stability. So more the number of this is called your alpha carbon atom. Alpha carbon atom, that means first carbon atom attached to the functional group. The more the number of alpha carbon hydrogen atoms, that means the hydrogen atom attached to alpha carbon atoms, more will be the hyperconjugated structures, and hence more will be the stability. Therefore, stability will be this contains say 3 alpha hydrogen atom is more stable than this one, which contains 2 alpha hydrogen atom, which contain only 1 alpha hydrogen atom, and this is contain no alpha hydrogen atom. So this is the stability order. In same way, we can also predict the stability of the compound. Say CH3C, this compound 1 is more stable than compound 2, which is more stable than compound 3, which is more stable than because here it contains 12 alpha hydrogen atom, here it contains 9 alpha hydrogen atom, here it contains 6 alpha hydrogen atom, and here only 3 alpha hydrogen atoms. As I have told you, more the number of alpha hydrogen atoms, more will be the number of hyperconjugated structures, and hence more will be the stability. Therefore, compound 1 is more stable than compound 2, then compound 3, then compound 4. Compound 1 contain 12 alpha hydrogen atoms, 2 contain 9 alpha hydrogen atoms, 3 contains 6 alpha hydrogen atom, and the fourth one contains 3 alpha hydrogen atom. Thank you. Rest will be discussed in the next class.